In these sections, 7E, F, and G, we're going to talk more about Venn diagrams and solve some problems with them. So in section 7E, we look at how to isolate different regions of a Venn diagram. So if I gave you a pretty standard Venn diagram, we've got our box, which is our universal set, U. Within the box, we've got two sets that overlap at some terms. We'll call them A and B, and they have an overlapping piece. We want to be able to pick out some different regions from here, and then shade those regions accordingly. So we'll just try a couple. So let's say I wanted to shade B complement. So B complement means, that little B prime means everything that's in U but not in B. So if I kind of use this picture up here, I'm not going to shade it on there because it'll get messy. I'm going to sketch a little picture. We would have A and B. B complement is everything that's not in B. So it could be in A, maybe. It's definitely in U, but it's not in B. So I'm going to shade everything except for B. So everything that's out here, this is B. Everything that's out there would be in B complement. It's not in B, but it is in U. Okay. What if I wanted to shade A intersect B complement? So A intersect B complement means that we find the complement of B, which we did here, and we intersect that with A. So we want to know what terms are both in A and in B complement. Well, the terms that are in B complement are all teal here, and then the terms in A are these, the whole A circle. But those right there are not in B complement, they're in B. So we don't want to shade those. So when I make my picture for this is B, this is A. We want everything that's in both A and B complement, and that will be here. So those are the terms that are not in B, but are in A. So the terms that are in A and also not in B complement are here. Okay. Let's try another one. So let's do A union B complement. So that means everything that's in A, or it's in B complement. If it's in one or the other, it's fine. So it either needs to be in A, or it needs to be in B complement. If it's in either one of those, we shade it. It does not have to be in both. It has to be in either one. So up here we had everything that was in B complement. So that's everything that's in B complement is definitely going to be here, because the union means everything in this or in this. And so we also need to shade these here, because so the first set I shaded, those were all the things in B complement. This little set, these little pieces are in A. So it's in A or in B complement, either one, and that's what we would shade there. So we need to kind of have a solid understanding of our different notations, union, intersection, and complement, and know how to pick those out on a Venn diagram. Sometimes whenever we're dealing, and more like a lot of times we're dealing with Venn diagrams, we don't have the entire set listed out. Instead, we just know the number of elements in each section. So if I give you an example, here's a Venn diagram. This is our universal set U, as always. This is A, this is B, and I'm going to put some little numbers in here and explain what they mean. So I'm going to put a 7 here, a 4 here, 5 there, and a 2 here. If they're in those little parentheses, that indicates that how many elements are in that spot. So this is not saying that 7 is here. That is saying that there are 7 elements in this section of the Venn diagram. There are 4 elements right here in the overlap between A and B, and then there are 5 elements over here in B, 2 on the outside. So what kind of questions could we answer with this? Well, also the 7 is just for this piece. Okay. So the 7 is just for that piece. Same thing with the 5. Okay. The 2 is everything out here in the universal set. So how about A? What are the number of elements in A? So the number of elements in A, these are the elements that are only in A. Those are the elements that are in both A and B. So to do the number of elements in A, this is A circle here, we need to include both of those. So 7 plus 4 is 11. There are 11 elements in set A. How many elements are in B? Number of elements in B. Well, the 5 represents the elements that are over here only in B, but then there's 4 that are in A and B, so those are in B. So that makes 9 total elements in B. This says how many elements are in A intersect B. A intersect B means A and B. How many elements are in both A and in B? Okay. So they have to be in A and they have to be in B. The intersection is the terms that they share. They share these 4 elements in the middle. How many elements are in U? U represents our universal set. The universal set is everything in the box. So that's going to include these 2 that are only in U, not A or B, these, and these. Okay? So the number of elements in U is going to be all of those added together, which is 18 total elements in U. Okay, what are the number of elements that are in A but not in B? So how many elements are in A but not in B? So not those 4. A, not in B. These are in B, so it's just the 7. Okay, so we need to be able to pick out how many elements are in each section of a Venn diagram if we know how many elements are in each part. Okay, the last section, which is 7G, we actually start solving some problems with Venn diagrams. And I'm going to do one example with you. I'm going to go to a new page, just in case I run out of room. So, in a factory, 56 people work on an assembly line. $47 work day shift. And 29 work night shift. Okay. Question is, how many work both day shift and night shift? So if you're going to work at this factory, you have to either work day shift or night shift. There are 56 total people who work on the assembly line. So that's how many people would be in our universal set. Okay, there are 56 people total that we're dealing with. 47 of them work days and 29 of them work nights. So if we add these two numbers together, we would come up with 76. So it can't be, they can't be disjoint. The people who work day shift and the people who work night shift have some overlap. There are people that work both. I assume not in the same day, because that would be crazy. But there are people that work both, maybe sometimes days, sometimes nights. They work both day and night shifts. So we need to figure out how many that is. Well, if we have 76, we've overcounted by 20. So if I draw my Venn diagram, all of my people, this is kind of a side note up here, okay? All of my people are going to fit into the category of night or day. I'm going to switch to a pen here. There are total night shift people of 29 and 47 that work days. But if we add those together, it's 76, and we only have 56 people, so we overcounted by 20. So we're going to take 20 people and put them in the overlapping section. So if I put 20 people as working both days and nights, we'll do days first. So days. There were 47. If I put 20 of them in the section saying they work day and night, there are 27 left that work only days. If there are 29 people total that work nights, and I put 20 of them in the combo category saying they sometimes do both, then there are 9 people left here. Let's see what those three numbers add to. We're hoping 56. 20 plus 27 plus 9. That is 47. Plus 9 is 56. Okay. So the question is, how many people both day and night shifts? That would be the overlapping section. 20 people do both. So we have to have an understanding of what the numbers in the box mean and to come up with how much it overlaps. Okay, this should help you get started on the rest of Chapter 7. This is your last topic before your quiz.